Hello friends, welcome back to another video lecture of data structure subject. In this video lecture we are going to learn about a linked list. Previously we have discussed about singly linked list. Now we are going to learn about doubly linked list. Okay, so in doubly linked list there will be three things into our node. Previously we will have only two things, data and next part, but now we will have three things. One will be the data, second will be the next, and third thing will be our previous part. This next is the address of this next node and previous is the address of this previous node. Okay, if we have only one node into our linked list, then previous and next both will be null and 3 is our data. Okay, so doubly linked list has two link fields. One link field is previous pointer and the other link is next pointer. Same as our singly linked list, we will create a structure, and that structure we will have three things: data, previous and next. Previous and next will be store the address of previous and next node. Okay, now representation of doubly linked list. Here in this doubly linked list we will have a head node, next node and this next node. So into doubly linked list can traverse into both direction, forward as well as backward direction. If we want to traverse in this direction, then that is possible, and also if we want to traverse in forward direction, then that is also possible. Note here one thing: in doubly linked list, head node's previous pointer will be null and last node's next pointer will be null. Okay, in linked list presentation of doubly linked list, we will have main three operations. First will be add, second will be display, and third will be delete. Okay, so now understand insertion operation. So insertion operation is like our previous thing. If we have no list into our linked list, then our first node will be our head node. Okay, if we want to add node 20 into it, then what we will do, we will just put our this node's next is equal to new, and second thing we will have to do is this new's previous is equal to head. Okay, so we will have to give address of here to here and previous to here. Okay, so this will be the insertion operation. Okay, now you can see here we will have to give temp next is equal to new, means this thing, and also we will have to give new's previous equal to temp, means this node's previous node is equal to this temp node, or we can say head node. Okay, so this is change into doubly linked list. We will also have to set our previous pointer. Now when temp is equal to temp next is not null, then we will do temp next, means if we want to add our node at the last position, then we will move further until our temp's next is equal to null. So here this temp next is not null, here this temp next is null, so we can add 30 here. So we will put our new node 30 here, we will give temp next is equal to new, and also give new's temp is equal to new's previous is equal to temp. So at that way we can add our node into this linked list. Okay, so this is add, this is temp, and this is new node. If very first node has to be delete, then if we want to delete this node, then what we will have to do, we will just make this node as temp node. Head is equal to head next, means we will declare our new head node head next, means this is our head and this is next part of it, means this thing. So we will declare this is head. Head previous is equal to null. Now this heads previous we will declare null, and temp next is equal to null. This is the temp and we will declare this is the null. So now we will have only two nodes into our list, this and this. This will be not part of this linked list. Okay, now if we delete any node other than the first node, means if we delete this node suppose, then what we will do, temp next previous is equal to temp previous, means this is our temp node. Temp next previous means temp next means this is this node, its previous means this thing. We will give into temp's previous means temp's previous means this thing. So we will put here from here, and what we will do, temp previous means temp's previous means this thing, its next means this thing is equal to temp next means this thing from here. So we will give here to here combination, we will delete directly this thing, so it will look like this. Now we will do this both path is null, so we can directly go from here to here and here to here. So this is deletion of 20. Okay, so this is doubly linked list. Now let's understand third part of our linked list, circular linked list. In circular linked list, what we will have, we can perform operation insertion node, deletion node, display of node, but in that thing there will be no null value into our linked list. We can create a circle into our linked list, means this is the last node but there will be no null value. We can go from this last node to this head node, means it will create a circle. If only single node is there, then in that next address its own address will be there. So this will be the circular linked list. In linked list implementation of stack, we will implement linked list by stack. So if we want to create a stack, then we will do new next is equal to top, means our new nodes next will be top, and top is equal to our new, means if we have added a new node here, then our new node will become top. If we add our new node here, then our new node will become top. If we want to delete this node, then our this node will be the top. If we delete here, then our this node will be the top. If we delete here, then this node will be the top. Okay, we can perform push, pop and display operation in this. Previously we have seen stack implementation by array. Now this is the implementation of stack by linked list. Okay, so we can also perform our presentation of queue by linked list. Previously we have seen by array. Now we can say that linked list presentation of queue. In linked list, head node will be the front node and last node will be the rear node. If we want to add some item, then we will enter after rear node, and if we want to delete some item, then we will delete this front node, or we can say this head node. So linked list presentation, linked list implementation for queue is very simple. Okay, so this is it for linked list. If you like this video, then like, comment and subscribe. Also share it with your friends. Thank you friends.